Our next exponential equation is part C, where we have the fraction 1/4 raised to the x power, and that has to equal 1 over 64. This one has fractions involved, and I know fractions can be a pain. The easiest way to do this one, to be honest with you, you're trying to raise 1/4 to a power, so you're actually multiplying 1/4 by itself. So you're trying to figure out the value of x. How many times do I have to raise 1/4? Well, how many times do I have to multiply 1/4 by itself in order to get 1 over 64? Okay, so what I would do is I would just start multiplying 1/4 by itself. So 1/4 times 1/4, that would be 1/4 squared. That is going to give you, remember to multiply fractions, you need to multiply across the top and across the bottom. So 1 times 1 is 1, 4 times 4 is 16. Okay, that does not give you 1 over 64, so keep going. Multiply that result by another 1/4. Okay, so go ahead and multiply across the top here and across the bottom. 1 times 1 is 1. 16 times 4 is 64. And so that gives us the right side of the equation. So we had to multiply 1/4 by itself once, twice, 3 times to get 1 over 64. And so that means the power that you had to raise 1/4 to needed to be 3. Okay, that's how one way you can get the answer. Okay, so because of the fractions, that's kind of the way I recommend doing this problem. All right, on to example D. 5 raised to the x plus 3 is equal to 1/5 x. Or sorry, 1/5. 5 raised to the x plus 3 power is equal to 1/5. Again, when you see these guys, start training your brain to identify this as an exponential equation. Okay, the x value, the variable, is in the exponent. Okay, so you're going to want to try to get both sides to be the same base. On the left side, we have base 5. And on the right side, we have base 1/5, because 1/5 is raised to the first power. Okay, so the easiest thing to do with this one, okay, if you're like me, I'd rather work with 5 than work with 1/5. Okay, no one really cares for working with fractions. So I am going to leave the left side alone. And it's actually really easy to change 1/5 into base 5. This is 5 to the negative 1. Okay. Remember what negative powers do. If you have 5 to the negative 1 and you want to eliminate that negative power, you do 1 over the something and change the sign of the something. So 5 to the negative 1 is the same as 1/5. Okay, so start training your brain to think like this. 2 to the negative 1 is 1/2. 3 to the negative 1 is 1/3. 4 to the negative 1 is 1/4. 5 to the negative 1 is 1/5, and so on. Okay, it's very helpful in these types of situations, because now rewriting that 1/5 as 5 to the negative 1 power, now the left side and the right side have the same base. They're both base 5. Now that the bases are the same, we can equate the exponents. So x plus 3 has to equal negative 1. Okay, now this becomes, see, the x is out of the exponent. Okay, this becomes an equation that we know how to solve. All I've got to do is isolate the x. Okay, so move the 3 over, and we're going to get x is negative 4. And that's it for that one. Okay. All right, part E. 4 raised to the x squared power is equal to 2 to the x. Okay, again, you want to try to make the bases the same. On the left, the base is 4. On the right, the base is 2. Okay, and remember I told you it's most of the time it's easier to change that bigger number into the smaller number. Okay, so let's do this. I have, let me get a different color here. I'm going to try to change that 4 into base 2. Okay, so I'm just going to rewrite the problem. I'm going to color code this. We have 4 to the x squared is equal to 2 to the x. Okay, so my x's are trapped in the exponent. Okay, so I haven't done anything yet. I'm just kind of color coding that 4 because that's what I want to change. I want to rewrite 4 as a power of 2. Okay, so 2 to what power gives me 4? Well, it's going to be 2 squared. 2 times 2 is 4. So whatever is in red is the same thing. 4 and 2 squared are the same things. Okay, 4 is raised to the x squared power. Okay, this is the same thing as having 4 raised to the x squared power. Okay, that's equal to this right side. Okay, and now we have a power raised to a power. Okay, this is when your laws of exponents come into play. Okay, you have to go back and look at your laws of exponents. Okay, when I have a power raised to a power, I multiply the exponents. Okay, so you're going to use that property. Okay, this is a power raised to a power. So over here, we're going to multiply the exponents. You're going to get 2 to the 2x squared power. Okay, you're doing 2 times x squared. That's 2x squared. Okay, that's got to equal 2 to the x. Okay, now that I have a power of 2 equal to a power of 2, you can go ahead and equate the exponents. Oops, yep. So this exponent has to equal this exponent. Okay, I cannot emphasize enough. You cannot equate the exponents until you have one power of the base equal to another single power of the base. Okay. All right. So now your x's are out of the exponent. Okay. This should be an equation that you know how to solve prior to this section. Okay. This is a quadratic equation. The highest power of x is the second power. Okay. So we know in order to solve this, we need to get everything on one side. So we're going to get 2x squared minus x is equal to 0. Okay. And then you need to either factor or use the quadratic formula. Okay. I'm going to go ahead and factor this one. Okay. I can take out an x from both pieces. Okay. That is going to leave me with 2x minus 1 equals 0. Remember, you can multiply back through to check yourself. This would be 2x squared minus x. And then you want to take each factor and set it equal to 0. So I'm going to get x equals 0. That's one solution. And then take the other factor, 2x minus 1, set it equal to 0. Solve this guy. To move the 1 over, divide by 2. I get x equals 1/2 or 0.5. That's the other solution. Okay. And again, you can check yourself by plugging these guys in to the original equation. Both of these x values should make this original equation a true statement. All right, so let's move on and try example F. Okay, I'm going to put a little line here so we don't get mixed up in the other work. Okay. All right, so I'm dealing with an exponential equation. The x values are in the powers. Okay, I need to make both sides have the same base. Okay, base 9 is on the left, base 27 is on the right. Those are not the same. Okay, you may be thinking, okay, let's change the smaller number into the, or sorry, let's change the bigger number into the smaller number. I cannot take 9 and raise it to a power and get 27. All right, so what you're going to have to do is change both sides. Both 9 and 27 can be written as powers of 3. So I'm going to do the same kind of color coding thing I did in part E. So let me write the original problem. We have 9, which I'll keep in red, raised to the negative x plus 15 is equal to 27, which I'll put in green, raised to the x power. Okay, so we need them to have a common base. We're going to try to rewrite both of these guys as a power of 3. Okay, so notice 9 is going to go in parentheses. We're going to rewrite it. It's still going to retain this exponent. And then on the right side, we're still going to have 27. as our base. We're going to rewrite it as a power of 3. The exponent will stay x. Okay, so 9 is the same thing as 3 squared. 3 times 3 gives me 9. Okay, so this is 9 raised to the negative x plus 15 power. And then 27 is 3 to the third power. 3 times 3 is 9, times 3 is 27. Okay, so both right sides here are 27 raised to the x power. Okay, so now my bases are the same. Okay, you cannot equate the exponents yet because you need to simplify the exponents before moving on. Okay, we've got to simplify these guys. Okay, once you've got the exponents simplified, after getting identical bases, then you can equate the exponents. All right, so remember, this is a power raised to a power. This is a power raised to a power. Law of exponents. Showed you this a minute ago. Law of exponents. Power raised to a power. Multiply the exponents. Okay, so let's do that. On this left side, the base is going to be 3. You have to multiply the exponents here. Be careful, you're going to have to distribute. Okay, and on this right side, multiply the exponents. So the base will be 3, the exponent will be 3x. Okay, like I said, you have to distribute on the left side because it's going to be 2 times all of this. So your exponent is going to be negative 2x plus 30. Okay, so that's what you should get at this point. Okay, all right, so now on the left side I have a base 3. On the right I have a base 3. My exponents are simplified, so I can go ahead and equate the exponents. This brings the x out of the exponent, so it's a lot easier to solve now. Okay, this is a linear equation, meaning the highest power of x is 1, so you just need to isolate the x and you'll be good to go. Okay, so let's go ahead and get all the x's on one side. So I'm going to add 2x to both sides. I'm going to get 30 is equal to 5x. And then if I want x, divide both sides by 5. So the x value that makes both sides of this equation true is 6. 6 is the solution to this equation.